Let's go through the derivation of arc length, another example of a simple formula from algebra being used by calculus. You'll remember that the distance between 2 points, let's say x1, y1, and x2, y2, is defined by the square root of the difference between the x-coordinates squared plus the difference in the y-coordinates squared, which I could conveniently rewrite as exactly what I said. The difference in the x-coordinate squared plus the difference in the y-coordinate squared. Take the square root. For some more general curve from calculus, we could consider this arc length to be the accumulation of the little pieces that are approximately linear. So let's take some segment here in the middle where that's my delta x and that's my delta y, and then we know that this segment length is approximately, at least, the square root of my delta x squared plus my delta y squared. And since this is going to be just one segment of the bunch, we should also apply the subscript I in each of the cases. This is a very convenient formula, but not quite in the form that we wanted. So what we're going to do next is factor out the delta x sub I from these two terms. That may not look convenient, but it works very nicely. And so that is approximated. I can take the square root actually now of the first term there, and that leaves inside the square root 1 plus delta y sub I squared over delta x sub I squared times delta x sub I. A convenient form, as I said. Then the whole arc length is going to be approximated by the sum for I equal 1 to n of these individual segments. It's going to be approximated by the sum, by substitution here, I equal 1 to n of the square root of 1 plus delta y sub I squared over delta x sub I squared times delta x sub I. That particular term looks a lot like calculus. In fact, if we take the limit of s as n approaches infinity, that is, we take the limit of the sum as n approaches infinity for I equal 1 to n, remember, this is, my s is going to be the integral from the beginning to the end of the arc. That square root term looks the same, except my delta y sub I squared over delta x sub I squared is my y derivative squared. And the last part is delta x, my very, very, very tiny width. So starting with the distance formula, we end up with a very useful formula for the length of an arc using calculus.